Okay, so again here we're asked to work out the magnitude of the acceleration of A and the tension in the string. So remember now the tension in the string is going to be the same all the way throughout, okay, because the string is inextensible and it's a smooth pulley. And the acceleration of A will be the acceleration of the whole system, okay. It's important to know, to remember that. Of course, it's accelerating in this direction, isn't it? Because when it gets released, we're going to fall down this way, and it's going to pull this up. All right. So that's the direction of acceleration. So again, if we use Newton's second law, okay, and we can say, look, at A, right, we'll have tension pulling up this object A, which is a weight 2g. That will equal mass times acceleration, and then at B, we've got then, of course, it's going down, so the weight will be pulling it down, take away the tension, resisting force, and then that will equal mass times acceleration. So we label it 1 and 2. Of course, then we need to add 1 and 2. Okay, so if we add 1 and 2, the t's will disappear, and minus 2g plus 5g is going to be 3g. And then if we add them there, that'll be 7a. Okay, so that means then a will equal 3g divided by 7. And if we work that out, you get 4.2 meters per second squared. Okay, and then once you've got your acceleration, you can sub it then maybe into number 1, okay, to get your tension. So sub in 1, so t, take away 2 times 9.8 equals 2 times the acceleration, 4.2. So then you get your tension, and that comes out to be 28 newtons. Okay, now part B now, right, you notice here we've got a part B. It says before the object A reaches the pulley. Okay, so obviously this has been pulled up. So it says before it actually gets the pulley, and 2 seconds after the system is released, the string breaks. Okay, find the speed of A when the string breaks. Okay, so what's important to note is, right, is that, with part 1 here of part B, right, what's important to note is that A is being pulled up, isn't it? Yeah, with a constant acceleration of 4.2. Okay, and because the acceleration is constant, right, we can use the equations of motion to work out what the speed is when this string snaps. Okay, and if we think about one or two things at the start, of course, the initial velocity is 0, yeah, because it's all stationary, and then the system gets released. Okay, so u is 0, and it goes upwards, isn't it, at an acceleration of 4.2. Okay, so it's not like falling under gravity or anything. Okay, it's not as if we can put acceleration to be minus 9.8, because it is attached to a string here, right, and it's being pulled up at that rate of acceleration. Okay, but because it's a constant acceleration, we can now use the equations of motion. All right, so the initial velocity is 0, acceleration is 4.2, and then we're interested, of course, after 2 seconds, and that's when the string breaks. So now we can work out what v is. So if we just simply use v equals u plus at, we can get our v. Okay, so we put it in. V will equal 0 plus 4.2 times the time 2, and you get 8.4 meters per second. Okay, right, 8.4 meters per second, and that's the velocity there of the string, right? Sorry, that's the velocity of object A. Okay, so when t is 2, okay, we can say particle A, okay, or object A, right, has a speed, has an upward speed of 8.4 meters per second. Okay, and then the string snaps. Now, when the string snaps, the string is no longer pulling it, and it's moving freely under gravity. Okay, and that's important to note that. Okay, so we can maybe write that down. When the string snaps, when the string breaks, particle A or object A will move freely under gravity. And if that is the case, then we can use the equations of motion again, where the initial velocity, of course, is now, if you think about it, when the string snaps, it's going at 8.4, right? So we call it the initial velocity now, because now we need to think of a situation where the string is snapped and it's going at 8.4, and remember, it's going at 8.4 upwards, isn't it? Okay. Yeah? the string snaps. So that means we take upwards as positive. Going back to our vertical equations of motion here, when we did vertical motion using the equations of motion. So upwards is positive, but of course acceleration then due to gravity is opposing that. Alright, so because it's opposing the positive, we'd write a to be minus 9.8. Alright, and what's the question say? Determine the time taken for it to reach the ground. Now, obviously a is going to keep on rising, right? This object is going to keep on rising, but at some point it's going to, because it's falling under gravity, it's going to stop and it's going to fall. Now, it's going to fall, and it says that a is 18.9 meters above the ground when the string breaks. So we're interested when s is equal to minus 18.9, yeah? Okay, because it'll rise, come to a stop, and then it'll fall again. So we're interested in when it gets to the ground, and displacement is minus 18.9. So we need to find then the time, okay? So the time would be question mark. And to work that out, we'll use s equals ut plus half at squared. Okay, so s will be minus 18.9. U will be 8.4 t, and then you've got half then 9.8. So that's 4.9. It's minus, isn't it? Because it's minus 9.8, so minus 4.9 t squared. So you've got that there, and you can see we're going to have a quadratic equation. What I maybe do here is, if I times it by 10, let's see what happens. I'll get minus 189 equals 84t minus 49 t squared. Okay, now I'm also thinking now, if we divide it by 7, because I think you can divide 189 by 7 if I'm right. Yeah, you get 27. If I divide 84 by 7, I know I get 12, and if I divide that by 7, I get 7. 49 divided by 7 is 7. So get everything onto one side. 7t squared minus 12t minus 27 equals 0. And I'm assuming now this will factorize. If not, we'll use the formula. So 7t in one bracket, t in the other bracket. Okay. And what have we got here? So 9 and 3 might work. 9 there and 3 there, I think. Okay, equals 0. So then we need to make that a minus and not a plus, I think. I think that works. Yeah, it works. So then we've got two situations for those times. Okay. We can say, well, that means 7t plus 9 equals 0, which means t will equal minus 9 over 7. Now that is impossible. You can't have a negative time. The other situation is t minus 3 equals 0, and of course t equals 3. That's much more sensible. 3 seconds will be our answer.